Yo, what is up, geometry students? Mr. Messer coming at you. 9.02 homework. One of the last videos of the year. I'm at school. It's a Saturday. I'm waiting for my calculus students to come in so I can help them study for the AP test. But nobody's in yet. So I'm just going to make this video. Okay, we are doing two things. We are solving equations. We are finding intersections. We need to understand the difference between the two first and how we're going to go one way and then we're going to go back and do the other way. Let's say I have an equation. I'm able to use a calculator for the question, like Desmos or your graphing calculator. I'll show you the graphing calculator. We are looking to find the x value or values in which this equation is solved, like when both sides equal the same thing. However, if we are asked to find intersections and the locations of intersections, we are asked to find like the solution to the system, which is an x and a y. So just letting you know two different ways. Like for this situation, if you're able to graph to solve, we would like you to turn this into two separate equations. You'd also move everything on one side and make it like a y equals 0 and a y equals other equation. And all we want you to do is to graph the two equations and understand that the intersections x equals -1, zoom out a little bit, and x equals 5 are the answers. So we could find that by separating the two equations, graphing them separately, and solving. So this is how we can solve any equation with a calculator. If you have a TI calculator, let me just show you how to do this. You would go into y equals, you'd graph y equals 4. This is the button for x right here, plus 5. You'd graph y equals x squared. Probably start with the zoom standard. Realize you can't see the intersection, you only see one of them. You could find the intersection by pressing second, going to calc, and finding the intersect. Pop over to the intersect you're trying to find. Realize since you're solving this equation, you just have x equals. You don't write the answer as -1, 1. You say x equals because you just have x's here. We can adjust our window, we can zoom out, or we can just expand our Y max. That's like how up and down we look. If I expand my Y max, I'll be able to look up more. You could also press a zoom fit is also a possibility, though that would be kind of crazy. So never mind. We just do second calc intersect and we find the other intersection. Pop over to the other intersection, saying, hey, which is the first curve you'd like me to find the intersection with? And you press enter. And they say, hey, do you want me to use this x squared as my second curve? And you say, yeah. And they say, hey, you want me to guess because it's using a numerical method to find the intersection? You say yes, and it gives you the x equals 5. Cool. So let's do the next one. To graphically solve any equation, you graph y equals 3 to the x and y equals 20. You split this up into two different equations. Graph. We see one intersection. We are attempting to find the x. Now, this is not a perfect number, and this is kind of showing you your calculator will always get you decimals. Sometimes we don't want decimals, we want exact answers. If you had decimal, but like don't worry about it right now. If you have Desmos up, you could even just type in 3 to the x and 20. Now, what's cool about Desmos Oh, it won't graph y equals 20. You have to graph y equals 20. Boom. Some people will try to type in just this equation and they actually find the spot for you, but they don't give you the number. So they actually kind of solve the equation for you, but you're not able to see the number where the intersection is. You can like guess, but there it is, 2.726. Okay, great. But now we're going to go the other way for the rest of the homework. I'm going to give you two equations. I'm going to ask you to find where they intersect. Now, we are trying to find the intersecting point. But to do this, we'll go the other way, which is we can't graph. Let's say we don't have a calculator. What we would do is set up equations like this, set the two equations equal to each other to find what is the x that will make both of the y's the same. You will solve this algebraically. You'll subtract 2x, you'll add 4, or sorry, subtract 4. When I subtract 4, I get negative 15. And when I divide, I get x equals negative 15 halves. And that is half of my intersecting point. To find the other half, you need to plug back in. So I'm going to find g of negative 15 halves. So you can plug it in here or in here. You'll get the same value. And if you don't, then you messed up. 2 times negative 15 over 2 minus 11. Guys, do yourself a favor. If you're multiplying by 2 and dividing by 2, the multiplying and the dividing of 2 will cancel. You have minus 15 minus 11, which is minus 26. Great. This is the same thing. You want to find the intersection. Well, we will set up an equation where the two equations are equal to each other. We will solve, but we will be ready to find the intersecting point or points. Here I'm going to distribute. I'm going to solve. Same side combine. Same side combine. Don't subtract 6 and subtract 6. Combine the 6 and the 1. I will add 9x to give me 12x. I will add 12 to give me 19. So x is 19 twelfths. So that means my y coordinate, and you need to work on using fractions because you will have fractions in your future. So this is a good time to do it. Is 3 times 19 twelfths minus 4. Now, I'm going to subtract 19 twelfths and 4 first and then multiply by 3. How do I subtract 4 as twelfths? Well, turn it into a common denominator. 4 over 1 turns into 12 over, multiply the top and bottom by 12. 12 times 4 is 48. 48 twelfths. 12, 24, 36, 48. 48 minus 19 is like minus 20, but 1 less. So that's 28, but 1 less is 27. So minus 27 twelfths. 27 times 3 twelfths. 0.9 twelfths. If I multiply by 3 and divide by 12, it's like dividing by 4. Divide the top and bottom by 3, you get 29 fourths. Cool. All right, now we're going to get into quadratics. We're finding the intersections, so we are looking for a point or points where the two equations equal each other. We'll have a shared solution. So you notice that we have different kinds of x's. We have x squareds and we have x's. When you have different kinds of x's, you're not allowed to do this and then divide by x and say x equals 3. You are going to lose a solution if you do that. So instead, whenever you have multiple types of things, especially with quadratics, the technique is to get everything onto one side, set the equation equal to 0, look to factor or use the quadratic formula, or you'll learn about completing the square when you're older. And that gives you x equals 0 and x equals 3. That means I have two intersecting points, one intersecting point when x is 0, one intersecting point when x is 3. Well, this should make sense. If you plug in 0, you're going to get 0. If you plug in 0, you're going to get 0. If you plug in 3, you get 9, 12. If you plug in 3, you get 12. So 0, 0, 3, 12. Okay. So it's going to be a lot of rinse and repeat deals where we will be doing the same thing every time, just understanding what to do and why. Cool. I have 4x squared plus 6x. I'm going to factor out a 2 and an x, or you could just factor out an x. And you get two x's, x equals 0. And then where's the x that comes out of this? Well, it's like when does 2x plus 3 equals 0? That's when 2x equals negative 3, subtract 3, divide, x equals negative 3 over 2. 2 points, x equals 0, y will equal 0. The other point's going to be harder to find. Negative 3 halves squared times negative 2 plus negative 3 halves. Maybe I'll do this one. Maybe that'll be easier because I don't have any negatives. So let's do this one. 2 times 3 over 2 squared, well, negative 3 over 2, plus 7 times 3 over 2, negative 3 over 2. This is 2 times 9 fourths, because 3 halves times 3 halves is 9 fourths. This is 21 halves, multiply straight across. This is 18 fourths. This is minus 42 fourths. So subtracting 18. It's so tough to do with negatives and positives. Subtract 20, but add 2. So I'm just going to go to 22, 24. Okay. And negative 24 halves. Oh, shoot. This could have been 9 halves. 24 halves is 11 halves. 12 halves. 12. Wait, what did I say the answer was? That's negative 6. If I have 9 halves minus 21 halves, I have minus 12 halves, which is minus 6. Look at that. Cool. Next one. We see we have different x squareds and x's. We're not allowed to isolate these x's. So I'm going to move everything onto the other side. I'm going to move everything onto the right side because I like to have positive x squareds. All right. Now, in this technique, we have x squareds and x's and numbers. We have to remember that x plus a number times x plus a number equals x squared plus a number of x's plus a number. Remember, if you distribute this, you get x squared, you get ax, you get bx, you get a times b, which means you have x squared plus a plus b x's plus a times b. We are looking to find the two numbers that add to get this and multiply to get this. Okay, and that goes here and here because they add to get the middle, then multiply to get the end. So I know that minus 6 and positive 1 will multiply to get negative 6, but add to get negative 5. So this is what we call factoring. And it's because we know about distribution that we know we can factor, or at least attempt to factor. Not everything is factorable. So we get x equals 6, and we get x equals negative 1. When x equals 6, I have 24 minus 36, which is negative 12. When x equals negative 1, I have negative 4 minus 1. Negative 4 minus 1 is negative 5. Hey, I got a calculus student. All right, I'm going to pause. We're back. It showed up. It was great. This is actually a plus. Change the question, my bad. We set the equations equal to each other. Going to subtract an x. Going to subtract 21. And that's why it needs to be a plus, so that I can factor the two values that add to get -4 and multiply to get -21 are -7 and +3, which means x equals 7, x equals -3. Where the intersections, plug it back into the original equation. If I plug in 7, I get 49 minus 21. If I plug in 7, I get 7 plus 21. You'll get the same thing. If I plug in -3, I'll get +9 minus -9. So that's 9 plus 9, which is 18. If I plug in -3, you get 18. Cool. All right. Now, what we have to understand is that sometimes you don't always have to move everything onto one side. There's only one version of x. You know, like when we have x squareds and x's, now we have a complicated scenario. We can't get the x by itself. We can't get the x squared by itself because they're not the same thing. It's like an area versus a length, two different things. But here, I'm only talking about area. This is something I can easily solve for by dividing by 2. I get x squared equals 25, and then by square rooting. X equals plus or minus 5. Why do we have plus or minus 5? Well, we've been ignoring this all year because we're in geometry. And in geometry, we talk about lengths. And when we're talking about like a length of a right triangle, we don't really care about negative lengths. So we've only kept the positive lengths. Yeah, pause. Now you notice if you plug in 5 and -5, squaring it will be 25 times 2 would be 50. Yeah, I'm going to get 50. Y will have to equal 50 there. Cool. Get something like this. I'll start by setting the equations equal to each other. Good graph to solve if I had a calculator, but I don't. I'm going to add 4. And when I add 4, I get 3. And to divide by 4, and I get 3/4. I'm going to square root, and I get plus or minus the square root of 3/4. Now, that's the same as the square root of 3 over the square root of 4, which is the same as the square root of 3 over 2. Cool? Or it's just square root of 3/4. So I got negative root 3 over 2. I got positive root 3 over 2. Let's practice plugging that back in. Now, this would be the easier one, and it is easier to probably plug in root 3/4 because root 3/4 squared is going to be 3/4. 3/4 minus 1. How do you subtract fractions? 4/4. 3/4 minus 4/4 is minus 1/4, and that'll be the same for both. Because if you plug in negative root 3/4 squared, you'll still get 3/4. All right. Well, what about this? Well, like many students may think, oh, for quadratic, we need to change the problem. I'm sorry for all these mistakes. For many of these quadratics, we need to like have all the things combined, and you might think that you need to distribute, but watch. I feel like I can get this square by itself by adding 15, by dividing by 3. And watch, I could square root both sides. Now, when I square root to solve an equation, I get plus or minus root 5. Well, I'm not done. I have gotten rid of the square. I would not square root the 2 because it's just squaring that outside squared. So I'm just going to have the square rooted go away. I have the plus or minus root 5, but now I'll add 2. And this is my answer. But what happens when you plug that back in? Well, watch. I mean, I could go ahead and know that the y coordinate is 0, but it's good to do this. Like, what if you plug in 2 plus root 5? Well, then you'd subtract 2 and square it and then add negative 15. Well, the 2 minus the 2 is going to go away. You have root 5 squared, which is 5. 5 times 3 is 15, minus 15 is 0. So I have 2 plus root 5 comma 0, and I have 2 minus root 5 comma 0. Sorry for all the errors. Add 3. Divide by 4. Square root both sides to get rid of the square. Subtract 3. And now we know I'm going to get 5 every time, but you can double check. If you plugged in minus 3 plus root 2, and then you add 3 and you square it, you subtract 3, the negative 3 and the positive 3 are going to go away. The root 2 squared is 2. 2 times 4 is 8. 8 minus 3 is 5. So you get both of these. Now, if you can't factor, always have the quadratic formula as a backup. I like to write it as this, which is the split up opposite of b over 2a plus or minus square root of b squared. I like to do this like in my head, like b squared minus 4 times a times c. That's 4 times 1 times negative 5. 4 times 1 times negative 5 is negative 20. All over 2 over a. My solutions are 5 root 2 plus or minus the square root of 45 over 2. I could write the square root of 45 as root 9 root 5, which is 3 root 5. What's great about this is that this is the location of the vertex. And we see our symmetry. We add and subtract this distance to our solutions, and we get the same, and we get our 2 zeros. Now, what is the y coordinate of the intersection? Well, like, I'm going to make it easy on you. It's your x times 2. If you multiply this by 2, you'll just get the top. Pretty cool. All right, another one. Subtract an x. Subtract 4. X equals opposite of b over 2a, so that's going to be positive 4 over 4. Plus or minus the square root, b squared, minus 4 times a times c, so that's 4 times 2 times negative 9, which is negative 72, all over 2a, giving me 1 plus or minus the square root of, this is 88 over 4. 88 is 8 times 11. which is 4 times 22. So I'm going to do root 4 root 22, which is 2 root 22. I am going to be able to simplify this. Divide the top and bottom by 2. If you 2 times root 22 and then divide by 4, it's really just taking root 22 and dividing it by 2. And these are my two answers. I'm not going to want to plug it in and get an answer, but it's kind of easy to do because it's just going to be this plus 4. Again, I would not want to plug it into the original one. This one, you will get the same answer, and you could try doing it. It's just going to take you a while to do. But if you plug it in here, and I have 1 plus root 22 over 2, and I add 4, well, the 4 and the 1 are going to give us 5. And I'm not going to be able to add the root 22 over 2 to that. And then if I do the other one, I'll have just the same thing, 5 minus. Cool. All right, you guys pick the best method. You guys solve. Watch how quickly I can do this if I practice enough. Bam. Bam. It says solve the equation, so don't want the intersections. This one, 7 and 2. Zero and 3. Can't factor. Four times 1 times -1 is -4. So that's going to be 20. Root 4 is 2. 2 over 2 is 1. So I just have plus 2 plus or minus root 5. This is my vertex. This is the distance to my solutions. Ooh, it's not minus 6x. Do your work.
I'm working.
No, you're not. You keep looking in here and saying, hi. Hi. You have a good weekend? I had a great weekend. Saturday, my kid was sick, so I did not do much. And also, I didn't feel great myself. But Sunday, we did a lot of stuff.
Did you cold?
No, she has strep.
It's terrible.
Did you go to prom? Are sophomores not allowed to go to prom? Respect. You can't even, like, as a junior, take a sophomore as a date? As a friend?
I'll see you tomorrow.
Sounds great. Do your homework. Look at this. You might think to do the quadratic formula, I'm going to divide by 2. And all of a sudden I can factor. Okay, so sorry for the errors in the homework. Let me fix that on the original document. That needs to be a -15. That needs to be a +21. Okay, peace.